We're on page 33, and the problem we're going to do is number 21 here. So we're going to go on and do number 21. So 21 essentially is a problem about the two main temperature scales that are used, centigrade and Fahrenheit, and to find the linear relationship between these. So what we're done is given two ordered pairs. We're told that the freezing point of water is 0 degrees centigrade, and that is the same as 32 on the Fahrenheit scale. So this represents a x value here, because we're going to make the x the Fahrenheit and the y the centigrade. So this represents one ordered pair, 32, 0. And then we're told that water boils at 100 and 212, and in this case the x value is the 212 and the y value is 100. So that's the information we're given, and we're asked in the first question to find the linear relationship in degrees centigrade, which is the y value, which is our y variable, to temperature in degrees Fahrenheit, our x value. So we're going to get some kind of an equation, y equals something x, a slope in front of the x, plus a b value, because there's not a very simple relationship between these two. It's not double or triple or something like that. It's a more complicated relationship, but it's a relationship that can be described in the form y equals mx plus b. So y equals some value of x multiplied by a value m, the slope, plus b. So the first thing we're going to do is we have to find this relationship in part A. So we've got the two ordered pairs, as I've said, x1, y1, x2, y2, which are going to be in degrees Fahrenheit and degrees centigrade. So x is Fahrenheit and y is centigrade. And here we have the Fahrenheit value, the x1, and here's the y1. That's the freezing temperature. And another set of temperatures which represents the boiling temperature of water is 212 on the Fahrenheit scale, is 100 on the centigrade scale. So given that, we can find the slope by taking the difference in the y's, 100 minus 0, over the difference in the x, 212 minus 32. And that's what we're given right here. What do we do when we substitute x1, y1, x2, y2 into the relationship for the slope? So 100 minus 0 is 100. And 212 minus 32 is 180. Now we could just cancel the zeros and then do 2 into 10 gives me 5, and 2 into 18 gives me 9. Reduce it that way. Or what you could say, 20 into 100 is 5, and 20 into 180 is 9. So we now know the slope. And because we know the slope and we know ordered pairs, we could substitute, for example, 32, 0, one of the ordered pairs into the point slope form, because we know m. So y minus y1 equals 5/9 x minus x1. And we could substitute 32 for the x1 and 0 for the y1. And if we did that, we would get y minus 0 equals 5/9 x minus 32, or just dropping the 0 here, obviously y equals 5/9 x minus 32. So here we would have the centigrade value, And if we knew the Fahrenheit value, we could calculate the equivalent centigrade value. So when we put this into this, we get this equation right here. So as I said, we can calculate centigrade given Fahrenheit. Now, why choose the 32-0? Well, you can choose the 212-100 ordered pair, substitute it back into here, and you'll get y minus 100, because y1 is 100 right here, equals 5/9 x minus x1. In this case, the x1 is the 212. So we get equation 2 here. So whether we use equation 1 or we use equation 2, these will give us the same value for y, no matter what value of x we put into the equation. We'll see that in part B, because in part B we're asked to calculate y, or the degree centigrade, when it is 86 Fahrenheit. So we can plug this either into equation 1 right here, right, this one here, or we could plug it into equation 2. So if we substitute x equal to 86 Fahrenheit, that's what we're given here, and we want to calculate the corresponding value in centigrade into 1, we get y equals 5/9 86 minus 32. 86 minus 32 gives me 54. I divide 9 into 54, I get 6. 6 times 5 is 30. So what we're saying here is that 86 on the Fahrenheit scale is 30 on the centigrade scale. Now, we use this equation. What if we use the other equation, equation 2, and we substitute it into 2? Y minus 100 equals 5/9 x. Instead of x, we're going to put 86 minus 212. And so this becomes y minus 100 is 5/9. 86 minus 212 becomes minus 126. 9 goes into minus 126 14 times, minus 14 times. And 5 times minus 14 is minus 70. If you want, you could do this on a calculator, but 9 goes into minus 126 minus 14. Minus 14 times 5 gives me minus 70. I transpose the 100 from the left to the right, and y comes out to be 30. So here we see whether we use this equation or whether we use that equation, when we convert 86 to centigrade, we get the same value, 30 and 30. Now, in part C, what we're asked to do is work the other way around. Given y, what is x? In other words, given a centigrade scale of minus 10 here, what is the equivalent centigrade Fahrenheit value? So I go back and I substitute minus 10 into equation 1. Let's just move this up a little bit here. So we're going to put minus 10 right here. Minus 10 equals 5/9 x minus 32. And now we're going to multiply. We've got a fraction here, a 9. We're going to multiply the left and the right side by 9 to clear the fraction. And when we do that, we get 9 times minus 10 gives us minus 90. 9 times 5/9 gives us 5, and the bracket stays the same. Remove the brackets and use the distributive rule. 5 times x gives us 5x. 5 times minus 32 gives us minus 160. And then we bring the minus 160 to the right side. I get 160 minus 90 gives me 70, and I still have the 5x, and x equals 14. So minus 10 degrees centigrade is 14 on the Fahrenheit scale. Now, I could put minus 10 into the second equation. See, it says here minus 10 into equation 2. This is equation 2. So if I substitute here, minus 10 minus 100 equals 5/9 x minus 212, then I'm going to solve for the x. And that's what I'm going to do over here. So I do that here. Minus 10 minus 100 equals 5/9 x minus 212. Here's the equation here, and I'm substituting minus 10. Minus 10 minus 100 gives me minus 110. 5/9 x minus 212. Now, here again, I've got the 9 on the denominator here, and I want to get rid of that. I multiply through by 9, meaning I multiply the left and right by 9 to clear the fraction, so I have no fraction. So 9 times minus 110 gives me minus 990. 9 times 5/9 gives me 5. And I get bracket x minus 212. I now use the distributive rule. Multiply 5 times x gives me 5x. 5 times minus 212 gives me minus 1060. I transpose the minus 1060 from the right to the left, add it to the minus 990, and I get 70. Essentially what I'm doing is saying plus 1060 minus 990 gives me 70 equals 5x, x equals 14. So you see I get the same answer whether I use equation 1 or I use equation 2. It doesn't make any difference, so that minus 10 on the on the centigrade scale is 14 on the Fahrenheit. Here, whether I use centigrade or Fahrenheit. The last part of this problem, at what temperature are the two scales, what is the value that makes on both scales the value the same? So what we're saying is y equals x, since the two values are equal, and I substitute that into equation 1. So if you go back to equation 1, let's look for equation 1 right over here. Okay, and we put this equal to x because we're saying that y equals x. We get x equals 5/9 x minus 32. And we could put y, leave the y here and make this into y. It doesn't make any difference. We'll still get the same value. But what we're doing is making y equal to x. So for the y, we're going to substitute x. This stays the same. We clear the fraction by multiplying both sides by 9. We get 9x equals, here, multiply this by 9. The 9 on the numerator and the 9 on the denominator cancel. I get 5. And then I'm just going to use the distributive rule. Get 5x minus 160 because 5 times minus 32 is minus 160. Transpose the 5x from the left side to the right side. 9x minus 5x gives me 4x. Still got minus 160 on the right, and x equals minus 40. So what we're saying is minus 40 on the centigrade scale is the same number on the Fahrenheit scale. Alternately, we could say y equals x in equation 2, for example, and instead of having the y minus 100, we have x minus 100. This x stays the same, and we're going to clear the fraction by multiplying both sides by 9. So we get 9 bracket x minus 100 here, and this equals 5x minus 212. Now, so if I multiply this by 9, I get this portion here. If I multiply this portion by 9, the 9's cancel, and I've got 5 times bracket x minus 212. So removing the brackets, 9 times x gives me 9x. 9 times minus 100 gives me minus 900. 5 times x gives me 5x, and 5 times minus 212 gives me minus 1060. We remove the 5x from the right side to the left, make it minus, I get 4x. Move the minus 900 to the right, I get plus 900. Minus 1060 gives me minus 60. X is minus 40. Note that if we solve the equation in terms of y, instead of x, we'd still get the same values. I indicated that before. So you could go back to the original equations and solve everything in terms of y, and you still get the same value. So whether we use equation 1 or we use equation 2, centigrade and Fahrenheit values are equal at minus 40.